Hi everyone, I'm Stanislav Erokhin. I am working as a Kotlin compiler lead at JetBrains, and today I'm going to talk with you about KMP libraries and their evolution. And we are going to go through different topics today. First, we will start with a review how the compiler is working, and basic terminology. Then we will discuss how the KMP library is published. We will discuss what hosts you need, what actual files we publish, and also we'll discuss some format changes that we are planning to do. Then we will look inside klib files itself, so inside our actual files that we publish, and talk about the compatibility, and also I'll share some fascinating story about Inline. But why do you need to know any of that? Well, first of all, it's just cool. I'm passionate about it, and I would like to share with you this amazing technology. And also, I would like, in the ideal world, everything should just work. So you just grab our stuff, and it just works. But we all know that we are not living in the ideal world, and sometimes something is going to be broken, or will behave in some strange way. And it's important for you to understand some details about the technology to be able to debug it, and also to have a common knowledge between the community and developers, so we'll be able to exchange details about the problems. And also, we would like to share how we are going to evolve that, so there will be no surprises for you in the future. And also, the amount of libraries, KMP libraries on Maven Central is growing rapidly. So even now, there is at least 2,000 people to whom this presentation is relevant. And by the way, how many of you are KMP libraries afters here? Oh, there is plenty of people. So for all of you, this presentation will be relevant. But I hope that the rest of you also will become a KMP libraries after the presentation. All right, let's start with a review of how compiler is working. You probably saw something like this slide already. So basically, our compiler consists of two different parts. First, we call front end, and then we have a back end. Yeah, we are using technology. We are using front end and back end words, and we are using them a little bit differently. So front end, this is part that analyzes your code and transforms sources to a special internal representation that knows everything about types, what actual function you call, etc. Then we have 4 backends, and every backend transforms its internal representation to class files, JavaScript files, SO files, etc. But let's discuss it a little bit in more details, and start with simple JVM compilation. And for JVM compilation, you basically grab all your sources, and then you have jar files as your dependency, and then Kotlin JVM compiler just produces you class files, and these class files later on packed into jar files. With Kotlin native, the situation is similar but a little bit different, because we have the same sources, KT sources, but then for dependencies, we are using klibs. This is special files that we are using for dependency distribution, for library distribution. And then we transform it to the klibs as well. And you can ask me, well, but where is the binaries? And we have a second part of the Kotlin native compilation that converts these klibs to the binaries. So every time when you run a compilation of your final application, it actually consists of 2 parts. One converts everything to klibs, and then the second that converts everything to the final binaries. And yes, I'm going to use word binaries for SO or framework files, and for klibs, I'm going to use term library. All right, but how all of that actually works and published to Maven Central? Well, basically, we grab the result of the work from Kotlin native compiler and Kotlin JVM compiler and publish it to Maven to Maven Central or any other Maven repository. And you can see that if you want to create a KMP library, you don't need to run the second part of the Kotlin native compilation that produces binary, because you just need a klib that should be published to Maven Central. All right, that's enough for overview. And let's start discussing how publication is working. But to do that, we first need a simple library. So here we have a simple library that consists just from the common code with one function. And also we have like 3 targets specified: JVM, iOS, and Linux. And what is going to happen if we'll just publish this library to Maven Central, to Maven local? Let's investigate what is happening with inside m.2 folder. We will see that there is 4 files that were published. Utils JVM, this is just a library standard jar file for JVM clients. Then there is 2 klib files, one for Linux, one for iOS. And then there is one additional strange jar file. This jar file contains all the information for like non-platform source sets. So common main or native main source sets that are shared between different native targets. But what is going to happen if we will try to do the same on Linux? You will see that iOS part wasn't generated. This is because currently we have a limitation that all the Apple targets could be generated only on macOS. So let's discuss what host requirements we currently have for library product generation. So right now, all the Apple targets, Apple binaries, could be generated only on macOS. And the same limitation applies for library generation and binary generation. But luckily, all the other targets could be generated on any other hosts. So you basically could, for example, take Mac agent and generate all the targets. So even today, you can just use a Mac machine to generate all the targets that you want. And a lot of people, even today, just use this setup for publishing this library. But unfortunately, you need a Mac agent on your TeamCity or continuous integration server. And sometimes it's not convenient because Mac agents are difficult to set up, and they're a little bit more priceful than other agents. So it would be wonderful if you could just publish the whole KMP library from any agent, for example, from Linux machine. And we are going to do so in 2.1, allow it in 2.1. But there is a nuance and some details about it. Of course there is. There is one limitation currently. That's you shouldn't use sintrop. I mean, you shouldn't add additional sintrop in your library. You will be able to use sintrop that's already published to Maven Central. But if you want to use new sintrop, then you still would need to use Mac machine for Apple targets of this library. But all the sintrops that's already published, you could use, including all our platform libraries, such as Apple SDK, Linux, Windows, etc. So like POSIX and like Apple SDK Foundation. Yeah, I forgot. And you will be able to generate klib, but you won't be able to generate the binary itself. So if you need to test Apple part of the library, you still would need to use a Mac agent for that. But for some cases, you don't need to do so, because if your library just like a common code, or you don't care about like a native specific targets, so your library like platform agnostic more or less, then it's enough for you to test it on one platform. And in this case, it's perfectly covered, this use case. So how we are going to achieve that? Well, we basically will divide two concepts. One is publication and generation of libraries, and another generation of binaries. And for binary compilation, all the same rules applies. So you will need you will need Mac machine to generate Apple binaries. But klibs you could generate on any host, except for Syntrop. And this will allow us also to change the format a little bit. And I would like to share with you how we are going to change the format. But before we jump into that, let's discuss how currently this format looks like. So we already discussed jar files and klib files that's published when we run publication to Maven local, for example. But there is additional metadata published alongside, .pom and .model files for Maven and Gradle metadata. And also, there is a lot of additional files that we publish when we publish KMP library. For JVM and Android, we publish jar or RR. For JS and WASM, we publish klib, and also we publish klib per native target. And also we have this additional jar file with meta information about KMP library. And of course, the metadata for Gradle and Maven. And it's a lot of files. And actually, we have a problem, because some parts of the KMP library metadata published inside Gradle. So to understand how KMP library is structured, you actually need to read Gradle metadata. So it's difficult to support KMP libraries in other build systems, such as Bacon or Bazel, because they're used to read Maven metadata, but not Gradle metadata. And it's also difficult for us to evolve the format, because we should evolve not only the format itself, but also think about how it interferes with Gradle metadata and some information stored there. And also, the dependency resolution algorithm is really complicated because of that, because we have a lot of different files. And error reporting isn't great at all. I mean, if we just, if the library don't have, for example, some specific target, then you'll just get some long error from Gradle, and we are unable to customize this error and just say to you, hey, this library don't have this particular target. Let's discuss a little bit how dependency resolution is working right now. So if you have an application that's using a library, and inside this application we have common main, JVM main, and iOS main, then we need to grab the corresponding parts of the library from Maven Central, for example, and resolve like common jar, JVM jar, and iOS klib independently, and provide them to the corresponding compilation. And in theory, if we, for example, screwed up in our Kotlin Gradle plugin, the horror scenario could appear where different parts was resolved to a different version of this library. And of course, this is not going to work because, well, if we have a different version of the library, then we have potentially different API, so it's undefined behavior. And we are working hard to make sure that actually that's never happening, but the algorithm inside is really complicated. And we would like to simplify it significantly and just ask build system to resolve KMP library. And then we'll just look inside this KMP library and figure out different parts of it and pass this into corresponding compilations. So we are going to move control about the different parts into our tool chain. So how we are going to do that? Well, pretty simple. Just pack everything inside one big file. Currently, we are using uklib extension for these files, but this name could be changed. But of course, not everything we can publish inside one big file, because we still have, for example, JVM clients, and they prefer use jar files, and this is convenient for them, of course. But all the other parts of the KMP library will be packed inside one big uklib. And also, because we're reducing the amount of different files, we will be able to use just a Maven coordinates for storing information about this library. And we don't need to use Gradle metadata anymore. Yes, it's most probably still will be generated, but there will be no details about KMP library inside Gradle metadata. And that will allow other build systems to support this new format pretty easily, because they could just use Maven metadata for resolution. And also, the dependency resolution will be simplified significantly because you need to resolve just one artifact, and that's it. And we will be able to evolve that more quickly because everything will be under our control. So our toolchain will be able to understand like how format is changing and what it should do with like a new version of the format. So how it's going to work approximately? So we are going to have a jar file as before, but all the rest is going to be published inside uklib file. And then inside this file, we will have like a folder for every source set and every native or other targets. And then we will have a special manifest file that contains like metadata information about KMP library. But that's not all. In some distant future, we don't know when, we would like to even remove the like native specific parts when all your code located in common main. So if you have just like pure Kotlin library, then it should be enough to just compile it once and then use for every target. We call this concept universal klibs. Unfortunately, we are not there yet, and we don't even have a complete design how it should work. But we are slowly going there, and this is our like vision. And currently, if you have even just common code, we would need to generate like all the targets for all the native parts, and that's fine. All right, when we are going to transform to this uklib format, so first step, but still all the targets will be generated for all the platforms. Approximately in Kotlin 2.2, because right now we have a design, but we are not yet have a prototype for it. And how we are going to organize the transformation from one format to another. First, we are going to deprecate the creation of the old format, because if you need to use a library that's already using a new format, you could just use a new compiler for it. But with reading of old format, the situation is a bit different, because if currently there is a library and users use it, then they should be able to use it. And if library is not yet migrated to the new format, then we cannot drop the reading for this library in our toolchain. But if at some point we will see that the whole ecosystem migrated to the new format, then we could like drop the reading of this format as well. But we are talking like years before that's happening. All right, we discussed how publication is working. Let's dive deep inside klib itself. By the way, klib is just a zip file, so you could just open it, as well as, for example, jar file. But let's start with the jar file. And inside jar file, obviously, we have class files, right? And inside this class file, we have just usual JVM class file and also a special Kotlin metadata annotation that store all the information about like Kotlin specific. So basically, we store all the front-end data here. So information about types, names, etc. But all the rest, including the body, is pretty standard class file. With klib, we have completely our own format, but some of its parts similar to what we have inside class file. For example, link data is basically the same Kotlin metadata with front-end information that we have inside JVM. and it contains all the information about all the declarations, but it does not contain information about the bodies. Information about the bodies we have inside IR folder, and here we have like different files, for example, IR declaration file that contains information about declaration from backend perspective. And also, we have like a special file for bodies that contains just all the bodies for all the functions. Also, we have like another files for all the constants, etc. You can see that we have a duplication a little bit here because we have information about declarations stored in two places, one for front end and another for back end. We are not yet sure is it fine or not, but it's current state of things. And finally, what is going on with this special .jar file that contains information about common main, native main, and all non-platform source sets? By the way, I tried to understand why we named it .jar and wasn't able to. So it's just like historical reasons. And inside, we have something similar to what is happening inside klib. We have link data here, and it also contains Kotlin metadata information. So basically, it's information from front-end perspective. But we have no IR folder here, so there is no information about bodies of the functions. So basically, there is no backend information stored. And also, we have like several folders inside this jar file because potentially there could be multiple non-platform source sets. So source sets that are shared between different native targets or or other targets, so such as common main and native main. And I guess that's it about what is going on inside klib files. And let's talk about compatibility now. So let's imagine that we have a scenario where we have an application and we have a dependency to some library. And at some point, we decided to update a version of this library to a new version. And there could be a case when we see some red code in IDE, or we just try to compile it and it doesn't work. And we are like, oh no, we should migrate this code somehow and waste our time. And this is typical case of source incompatibility. And despite the problems that we should do some work, we still able to do so. So for example, if library A, after just rename some functions, we could just, migrate our application because we control the sources. But in the reality, everything is a little bit more complicated because we are not using just one library. We're using multiple libraries. And these libraries use another libraries. And at some point, if you'll just update one library, it has a dependency to a new version of another library. And it could happen that, for example, library C was compiled against library A 1.5, but on runtime, it will be given with 1.6 version. And if library after A renames some function, we potentially could have like no such method exception on runtime. And this exception happening from like insides of library C, because library C calling some function that was renamed in library A. And there is no simple workaround because we need to change the code of library C somehow to make it work again. And this is a typical case of binary incompatibility. So binary incompatibility happening when there is a library compiled against another library and already published. So it's more important because there is no workaround, so it's important to keep binary compatibility. So should you care about binary compatibility? Well, if you're just application developer, then you shouldn't. But if you're a library developer, you should because, well, you want your library to be popular, and at some point, it's going to be used in other libraries. And potentially, you could have the situation that I was describing recently. But we have a special tool for you to help you with that. It's called Binary Compatibility Validator. This tool basically creates a dump of all your public API. So during release of new version, you could just compare dump from previous version with a new version and see that you keep all the functions, all the public functions that were present in previous version of the library. It supports JVM from the beginning, and we added experimental support for klib, so please use it. And also, I would recommend you to watch a talk from Leonid Startsev from previous Kotlin Conf, where he, in details, explained how to involve your library, so you won't break your clients. All right, I promised you to share some fascinating story about Inline. I promise it is going to be the last one, but it's a little bit more complicated, and I'll just explain what is going on here. So we have this style library and two versions of it. And in 1.5 version, we have an inline default color function that returns red color. And in 1.6, the color was changed to green. And also we have a drawing library that using this style library. And also we have this application that just draw the circle and then do the same, but directly without asking draw function to do this work. So what is going to happen here? Let's discuss first what is happening on JVM. Well, first of all, during the drawing library compilation, we will inline the default color because it was compiled against 1.5 version. We will inline red color, so this draw function will be able to draw only red circles. But we will see, if we run our application, that draw will draw just red circles because it's not aware about any other colors because default color was inlined. But if you call default color directly, we'll draw, of course, a green circle because in new version of the library, color was changed. But what's going to happen if we'll use a native? And you'll see that both of them are green. What is going on here? And why it's happening? So on native platform, we are not doing inline during library creation. So right now, when we create a library, inside this library, there will still be a reference to just a default color functions. So it won't be inline to red. So this function is not aware of the color of the circle that it's going to draw. And inline happening only during the application binary creation. And during this creation, we are using a new version of the style library. And because of that, we use a color green for both places. So it's inlined into the draw function and also inlined to the main function. And we should choose between two behaviors, between JVM behavior and native behavior. And you could think that, well, it seems like native behavior is better because it's more convenient in this example. But in reality, it is not, because what is going to happen if you'll just remove the inline function? And you'll see that on native, you'll have an exception, because it will try to find a default color function during binary compilation, but won't be able to find it. On JVM, it will work, because it was inlined into drawing library, and that's it. So on JVM, you could more or less safely remove inline functions from your library and keep your binary compatibility. And this property is important for us, so we are going to change the behavior to JVM1. So to recap all of that, for JVM, inlining happening during library creation, and for native currently, inlining happening during application compilation. But we're going to change that and do the same as on JVM. So we will inline it during library creation. And we will release this change in 2.1 or 2.2. We're not sure here yet know when exactly. We're currently working on the prototype. All right, let's recap all the changes that we are planning to do in our ecosystem. First, in Kotlin 2.1, you will be able to generate all KMP library from any host, except for Syntrop klibs. Then we will change a format, so we will plug together into one big file, probably in Kotlin 2.2. And then we will unify how inline works across the platforms. But all of that is not a commitment, it's just our current plans. And that's it that I have for you today, and now there is some time for questions.
People who can see me, you can approach this mic to ask your question.
Hello? Yes. Hey there. Thank you for the talk. You said that the universal klib, where if you have only common code, then it would need to be compiled to all the targeted versions, is in the distant future. I'm curious to understand what are the roadblocks and what are the things that you haven't decided, and what are the things blocking you? Because from my point of view, now that you have this universal front-end IR, you could just serialize it. So what's preventing you from achieving that goal as of now?
Yeah, thank you for the question. Well, you saw that currently for common main, we are not storing IR at all. And there is a reason for that, because we are not sure how to do this. So, because let's imagine that you have expected inline function. So how it should work. And because from if you have a library that's using this expect inline function in your in its common code, then it's from some perspective it should inline it, but from another perspective it cannot, because only platforms know about the real body of this expect inline function. So there is design questions like that we still need to figure out to make sure that everything actually working. And also, there is a slight format difference between, for example, JS, WASM, and native backends inside IR format, as well as a front-end format that we're storing. So we need to unify all of that, solve all these complicated questions about how compilation actually should work, and then we'll be able to release universal klibs.
Okay, thank you very much.
Hello. Thank you for the talk. That was really informative, really cool stuff coming. I wanted to know, do you have cinterop klibs publishable from the Linux platform for all iOS or Apple systems on your roadmap? Is that something that could happen in the future, or is that indefinitely blocked?
Yeah, we have this on our roadmap, and the main blocker for that currently is that inside Syntrop klib we have LLVM bitcode stored, and it's difficult to deal with this compatibility and even this production, because for Apple system we have a special version of LLVM that generates this bitcode, and it's difficult to do on other platforms. So we're planning to try to eliminate this bitcode stored inside these Syntrop klibs, and when we're able to do so, potentially you'll be able to generate syntrop clips if by some magic you were able to deliver on Linux headers for your library. And that is not trivial sometimes.
Okay, thank you very much.
Hi, thanks a lot for the talk, super informative, and thanks for doing all of that. I had a question about language version. Like if I'm doing a JVM library, I can use latest KGP and set language version to 1.5, 1.6, and all the consumers can keep using all tools if they want to. Do you see a future where this could also be the case? As far as I know, this is not working for klib, right? If I'm using latest KGP, it's always going to generate klib using the latest format. Do you foresee a future where we could do this using latest tools, but build klibs for using old formats?
I don't think so, because it's difficult to keep generation of old formats supported in our toolchain, because even reading of old format is really complicated. And also, we don't see like a demand for that, because unfortunately, the support of new Xcode version happening only in new version of Kotlin. So during the application development, you should use a new version of Kotlin anyway. So I don't see like a clients that actually will be using an old compiler, and only these clients actually need the old format.
Do you have guidance how long we should wait until we update the tools? Like K2 is out, should we update all our libs to use K2 now and ask everyone to update, or should we wait a couple of weeks, months?
Well, first of all, I think it's for JVM, it's definitely safe to
for JVM is
update to K2, and also like during the next Xcode release, it's definitely safe to like update everything to K2, because everyone will need to use a K2 compiler anyway. So
gotcha.
if you're going to wait like for half of the year, top.
Okay. Yeah. Cool. Well, thank you so much. Thank you.
Hello, thank you for the insightful talk. I had a question about the universal klib thing that you are planning, where you can kind of compile but not really compile a library, say on Linux that targets iOS, for example. Is it possible to use another library that relies on a specific C interop, say a third-party Objective-C library? In another library, so can you have a transitive dependencies and build from Linux, or as long as just one dependency is not a universal one, you need to use a Mac to be able to build for iOS targets, for example?
Let's divide it into two questions. First one is like, what is going to happen if you're using like other libraries that's using syntrop inside? Could you, for example, generate a library on Linux for Apple if you're using transitive, if one of your transitive dependencies is using Apple syntrop inside? And the answer, yes, you can do that. And about like universal klibs and how they're going to work, right now there is no details. Like, would you be able to use like just other universal klibs, or will be able to use other libraries as well? And typical example is actually coroutines, because coroutines is not going to be a universal klib. It's obviously will have like platform-specific parts, but we need to make sure that it's possible to use it's inside universal klibs, because it's like core library. So we somehow should achieve that, but how exactly, we are not sure yet. No.
Okay, thank you, makes sense.
I guess that's it. Thank you, everyone, and don't forget to vote.